Thank you all for coming. So yeah, I'll be talking about Dart, and you might surmise from the context that that is a programming language. And you might actually infer from the slide that it is a programming language being developed at Google. And we'll start with an overview, and there isn't time to really go into every detail of Dart, but we'll try and give you the high-level view and then go deeper into a couple of things. Many of which I've said before, different talks are on the web and so forth, but some of which are new, just so I won't get bored talking about this over and over again. So why are we doing Dart? Why a new programming language? At least this audience, I don't have to explain why a new programming language. That inane question is one of the things I really, really hate answering. It's like, why progress? Right? But it's a very common question. My favorite example that I like to give in all kinds of talks, because it fits with everything, is when the Fortran team presented the very first Fortran compiler to John von Neumann. He told them, why would anyone want more than machine language? So nobody's perfect. And the question is very apropos here, because we're asked a very similar question, right? We're out to improve web programming. That's because we're lazy, right? Look for low-hanging fruit. Essentially, something that can easily be improved, you have a better chance of improving. So something that has lots of problems is promising. But also we're asked, like, why, we have, there is a language that's used in web programming, and why would you do something different? Because, well, there's a real difference of opinion here as to, JavaScript, to me, is the assembly program of the internet. This has been said here by me, by Eric, by other people over the past 6 years at least. And there are other people who think that they should actually program in it directly. And that's good that people have choice. We believe in choice. People should be free to have options, and we're out to give them another option so that they don't have to program in the assembly language. Now, web programming is great and something we're really keen on at Google, obviously. And it has all these well-known advantages that you know about. Zero install, it automatically updates, and it's ubiquitous on every, phone, pad, and peripheral that you can imagine, and on real computers too. So that's good. But when things are so good, there's always a catch, right? There's a but. It's a really huge, huge but, which is this stuff really doesn't work well if you're trying to develop major components of software. It's nice for these little scripts. Work well. I'm not going to say that it works well for anything, in my personal opinion, but you can make it work for this kind of small things for which it perhaps was designed. Not that I'm sure that, in fact, I don't believe it was designed. I believe it, its designer explains why he didn't have the opportunity to really design it. It's sort of one of those historical accidents, right? A language won the lottery. And that's fine, but if you try to build now today, people are trying to build real major applications, and the web isn't quite suited for that. It's getting there, and we aim to make it so that you can do that without too much pain. So there are problems, and in our view, and these problems I've sort of categorized them into two major areas. There's probably more, but there's a lack of structure, right? JavaScript is a very flexible language, but by the same token, there's very little structure that you can latch onto. And this is a problem at many, many levels, right? There are many people program in JavaScript. Only a tiny fraction of them actually understand how the actual model works with the prototypes and how they're wired together and so forth. This led originally to performance problems. And many people have worked to improve immensely that performance, including people at Google, right? V8. The Dart team is led by my good friend Lars Bach, who made JavaScript fast, and other people like Cass Perlund, also people who are on the original V8 team, and really revolutionized the perception that people had of what JavaScript could do in terms of performance. But they're not actually satisfied, and I tend to believe them, that there's a limit to how far you can go, and there's a problem of predictability, right? All these fancy, now there are several others that are competing, right? Several good implementations of JavaScript in terms of performance, but you can't really rely on this, because if you go outside the sweet spot the kind of patterns that the implementers have tried to make work well, you can fall off a cliff very easily. JavaScript will let you do things that really can't be plausibly optimized, and suddenly you find that, it doesn't optimize this sort of thing, and now I'm hosed. Something with a cleaner model will let us optimize better. So that's one aspect of performance. Then there's the problem of startup, right? There's no intermediate format, so generally you suck in, if you have a large application, you have lots of code, and it has to be parsed and brought up and everything all at once, and there's a startup problem. And that's the flip side of the fact that every time you can get an update. And and I'll show later, there are people who specialize in managing this process, telling you how you can load your scripts, in what order, how much, how you can cache, right? All kinds of problems that application programmers really shouldn't be, unless they've committed serious crimes, should not be forced to deal with. And so we want to make that, not everyone should be exposed to that. Then there's a problem of tooling. Again, it's kind of hard to tool a language like that. It is possible. One could build much better tools than are out there now, I'm pretty sure. But, it would be nice. More structure helps you tool stuff. And the thing that really bothers me most of all is the fact that basically if you're trying to build a large, maintainable application using this stuff, well, I don't think it's the kind of thing that I want to use. And I'm not the only one. Then there's a whole other set of issues that are equally painful and perhaps more widely agreed upon. Even the people who like the language agree that there are other problems, and they've sometimes argued that maybe we should focus on those other problems as well, right? Lack of standard libraries, whether it's collections or UI. There's the DOM, of course, but I mean real UI. So something you'd actually want to work with model view controller of some sort or something even higher level. There's no standard, right? There's lots of things out there, and they're each with their own pattern, and how do you fit them together, and so forth. Communicating between client and server, right? We're going through an accident that was invented here at Microsoft, and I'm sure they're very sorry they did that. But that has enabled a lot of interesting things. But it's a very low-level plumbing, right? We want to think at a higher, more abstract level. So in other words, there's lots of low-hanging fruit, lots of things that can be improved so that you can create large applications. If you kind of want to get most of you are probably familiar with JavaScript, but if you're not, there's there's fun things, right? So WTFJS.com, go there. These are the people who set that up are JavaScript programmers who actually like JavaScript, but they still, there's kind of most of their examples are focused on one of JavaScript's real problems, which is sort of coercions gone mad, right? The lessons of PL1 were not really applied. This is a problem other languages have, PHP or whatever, right? What's tempting in the short term to conveniently coerce, these things compose. The beautiful thing is that in computer science, errors are compositional. They compound and grow, if little errors grow into magnificent mushroom cloudy kind of things, right? So those are some of the problems, and some of these, to be fair, are being fixed in whatever future version of the standard. There's strict mode, there's ES5 and 6 and so forth, and if you wait long enough, some of these things are less of a problem. If you really want fun, though, there's this really cool video. Search for JavaScript and Watt. I think the site is something like destroyallsoftware.com. So you can see what spirit they're working in. But there's a video there that is just hilarious. It's a stand-up comedy of programming languages, and the guy knocks Ruby as well. I mean, in sort of more, he's not as mean-spirited as I am, let's say, but it's still it's good stuff. But this is actually, I think the problems are actually more than these small problems are rooted more in the prototype model, in the lack of classes, and all kinds of things. And maybe classes will get added at some point to JavaScript, maybe not. I can't follow the back and forth, but the question is when. And then there's the whole platform issues. I gave a talk at the San Francisco JavaScript meetup about Dart, and another one of the guests was a guy called Steve Souders, who works at Google as well. And he's a specialist in making web pages fast, and he has a couple of books on that. Look him up. They tell you all kinds of things, where to put your script tags, where to put your CSS, put it at the beginning, put it at the end, up to the real professional job, like programs like Gmail, where code is put in strings in the DOM so that you can avoid loading, have the browser loading it when you don't want, and then you can go at your leisure, pick the string out of the DOM, eval it, and extend your program that way. Cool stuff in a way, but maybe not the pattern we really, have to learn in order to make large applications. So it's amazing what people do to do large applications. You can do really neat large-scale applications on the web today. And Google has been among the people that pioneered that, right? But, it shouldn't, there are easier ways. We really think it needs to change, and it needs to change soon. So therefore, being language heads, if all you have is a hammer, etc., if there's a problem, you need to fix your car, you invent a language for it or whatever. So really, our goal is that web applications should be competitive with native applications in terms of their look and functionality and performance and ease of development. Of those three, basically, it's sort of right now, it's pick two, right? You can do all kinds of things, but you can't get all three of those, and that's really all we want to do. So there's a little example of the kind of thing we want to do. Let's see. Is this going to work? Do I still have a network connection? Yes, I do. So this is a demo app that we set up, and it's called Swarm, and it's just some sort of news feed reader. So, you can scroll these things, and you can scroll them. Well, maybe this one is wrong. This one doesn't have enough horizontal stuff, but if you do have enough horizontal stuff, you can kind of scroll it, and you can go and look at things, and it's a pretty nice app. It works on an iPad with touch from exactly the same code base, and is still performant. And basically, if you could do that for all your apps, you wouldn't need the plethora of native applications of different kinds. I'm sure this is not welcome news to everyone, but that is our goal. We've got a screen that's too small here, but let's go back to wherever we were. Okay, this is wrong. So yeah, web applications sometimes they need to be improved, right? Because this thing, as you can see, has this little annoying problem, which we'll probably encounter again. But again, if they didn't have to work so hard on these weird tricks, maybe they'd fix this. So this is the kind of thing we're trying to accomplish. And there are two enormous constraints. These are the worst constraints I've ever had to be involved with in a language design. One is that this has to be very familiar to the large body of working programmers out there, right? It has to be totally mainstream. These people are not represented here. And they're not really represented by Googlers who we're developing this for either, right? These are people who just want to get their job done. They do not wish to debate, the merits of prototypes versus classes or type theory or any of these things. So it has to be, we can't innovate too much. Innovating is easy, but the challenge here is to improve things without innovating too much, keeping it familiar. The other thing is to compile, to have a nice model and compile it efficiently to JavaScript. And if you've tried to compile a nice language to JavaScript, you know that some of the problems in the language underneath creep up, and it's very hard to deviate from those choices while maintaining efficiency. And again, it depends how much resources, how much expertise you have, how much time you have, and so forth. So at Google, we have a modest amount of expertise and time and resources, so we might be able to pull this off better than small efforts that people are doing everywhere. So what kind of language is this? Well, as you can see, that's motherhood and apple pie. It's very, very boring, right? And people, we've gotten criticism of being too, not radical enough. Well, where are your monads? But again, as I said, we're aiming at a slightly different audience, and the monad-free audience. And so we're not trying to invent the wheel. However, so as not to bore you entirely, there are a few kind of cool things. Not that they're actually new. They are, let's see. Yeah, they're mostly 20, 25, 40-year-old ideas whose time has come. And yeah, I say actor-based concurrency with some trepidation because Carl might actually be here somewhere. Yeah, and yes, it's not functional. We call them isolates to be honest. Most of the time, isolates are, no shared memory, no shared state concurrency, message passing, but they are inside regular, boring, programs, right? So that's kind of what it is, and I will talk mainly about the two highlighted things because they're things that I know and love and might have something to say, and they're just a little bit, tiny bit innovative, perhaps. So just again to continue the overview of how our evil plan to fork the internet will proceed. The first part is Dart2JS. Dart2JS is a Dart to JavaScript compiler. Because JavaScript is everywhere and we anticipate it's staying everywhere. We're not out to take JavaScript away. We're not that stupid. I personally, if I could, I would, but Google probably wouldn't because there are many people who actually love JavaScript at Google. And so, and anyway, it's not plausible to do that. But we are compiling it so it'll run everywhere, right? And people will have the choice whether to use that or use JavaScript or use any of the 15 million other languages that will end up being compiled to JavaScript, some of which will eventually work well enough that you might actually want to use them, right? And so our goal there is to ensure that your Dart code written and compiled to JavaScript will be as performant as your handwritten JavaScript, and we're pretty much there for the most part. There's some size issues, but in terms of speed, we're actually doing fairly well. Dart2JS is sort of the third generation of this that's being worked on. The first Dart to JavaScript compiler was written for bootstrapping purposes in Java. Then there was another one that was written in Dart, which Dart2JS is morphing from that one to a new backend. That's an SSA-based backend. Basically, because without the SSA analysis, it's hard to both get the performance and keep the semantics, right? So the first two versions have cheated on the semantics and where convenient, and we're getting to a version that will be totally compliant and still maintain performance. Then there's a VM, right? So one of the goals, of course, is if you're doing web programming, there's some component that's on a server somewhere, and you'd like to write it all in the same language. Some people use Node.js, but I think I've sort of indicated what I think of JavaScript as a thing for humans to program in. And so we would like you to program in Dart end to end, and essentially. This isn't quite here yet, but eventually you'll message pass, right? Your server is just going to be another isolate that you talk to and you send messages to, and you don't ever worry about whatever HTTP and XML and all that's good stuff. Yeah, there's an IDE story which is based around a hollowed out version of Eclipse. It's not an Eclipse plugin as such because we tried that, it didn't work very well. Rather, it's kind of retains some of the Eclipse feel, which there are people who really like that stuff. And it does come up in a reasonable time and so forth. It's kind of much lighter weight. It's a Dart editor. And there'll probably be other answers to that question, from either third parties or whatever over time. So that's kind of the general picture. Now, if we want to know what it's like, well, you can go to this site. try.dartlang.org, and what's running there is basically Dart-C, the first generation Dart to JavaScript compiler, which is running on App Engine and lets you do small experiments with Dart. That's the first way to try it. And of course, you can go download the whole SDK if you're serious about this. There's a community that's already doing that sort of thing. But for a quick and dirty experiment, you can use dartboard. So we can actually probably make it bigger. No, we can't. Well, let's forget about it. We'll go to this. I don't know if you can see this stuff. Can people in the back read the code? Or we can probably try and do something. Is that better? Yes. Okay, so this just, so you can see what the language looks like. It looks, dead common as the British say in their egalitarian style. So basically, you've got a class. It's named point, as you can figure out. You've got a function main that isn't in a class, so you can have top-level functions. That seems popular with people. The main function is creating one point, creating another point and calling a method on it. Then it prints stuff. So basically, the printing uses sort of string interpolation in a fairly common scripty style. Basically, the $ marks that you're escaping to something. Then the curly braces delimit an expression. If the expression is a single identifier, you don't need the curly braces because people's fingers are very delicate and they must be preserved. And what are we doing with this? We're actually taking the 2 points that we created before. We're adding them in that expression with plus. So yes, you can do what's commonly misnamed as operator overloading, but of course it isn't operator overloading. It is methods that have names that are usually perceived to be operators, right? It's just a plus method on points. And that plus method, identified by the keyword operator for reasons I cannot understand, is right there. So you add another thing, and you can see there's no types to be seen anywhere. It's a dynamic language, right? So we can point, we can add the point. There's a syntax that you can write functions either the way the distance function is written with curly braces, the usual way, or there's this shorthand notation with a fat arrow where the thing to the right of the arrow is an expression, and it's interpreted as return that expression. Right? So if you have a single expression, you have a slightly more concise notation. Some people really care about that stuff. And I think it should be fairly obvious what's going on. There's a little bit sugar in the constructor, right? So we have constructors that don't have the problems classic constructors do. We can have factory constructors that take things from a cache or produce instances of a different class. I'm not probably going to have time to speak about that. This is a regular constructor that is just producing point up there at the top line, is just producing a new instance. There is this sugar with this dot. What this means is take the two formal parameters. The first one is going to be assigned to the X field of the class of the instance, and right. So you don't have to write that boilerplate, right? Again, keeping people's fingers safe. Very, very deep principle of programming language design. So this is kind of what it looks like, and we can run it. And apparently these points are 50 apart, right? So that's kind of a first view of this. And oh my God, no, we're not going to do that. We're going to guess where we are, and then no, that won't help because I can't quite. Yes, see this nice thing? The button here is designed carefully to be on the side, so you can't both see these and this at the same time. So in particular, at the end, there's a menu that would let me start from that point, but I'm not going to get at it, so we're just going to I will file bugs about it. This is the first time I've been using this stuff to present, and I will file bugs because this is not good enough. So that was the overview, right? And I don't know how many of you had heard about Dart before, but all of this is, in more detail on talks in various places that have been videoed on the web and so forth. And now I want to talk about something that is really cool and dear to my heart, which is optional types, the one true way. So everyone's familiar with mandatory typing, right? Statically typed languages are almost invariably mandatorily typed, which means you have to have the types. Otherwise, your program is verboten, right? If it doesn't pass the type checker, it is not a program at all. It is an illegal, thing, and you just throw it out. That's the norm. People have for many years realized that perhaps this is not the best state of affairs. Of course, there are people who swear that it is religiously the best of all possible worlds, but we don't think so. Basically, there's a number of problems. Sometimes your type system isn't smart enough to figure out what you're doing and won't let you do a program that is quite elegant and effective and whatever. There are people who swear, no, I never have such programs. I'm always happy with my type system. If all you have is a hammer, etc. If you've worked your whole life in that framework, you sometimes don't realize that there are interesting things that you can do. And now these things are trending together. Like Donna yesterday had this example of these type providers, right, which is a way to use compile time reflection and staged execution to accomplish something that you would very easily accomplish if the type system wasn't in your way, which is very standard practice in dynamic languages to, basically read some XML or read some schema and dynamically create the type you want, right? So instead, you can go through these hoops, and then you actually have the types, and there's some benefits to that. So these worlds are converging. They've actually found that there are some problems they couldn't handle in the traditional way. So that was kind of interesting. More crucial to us in this context is the fact that types impose workflow. Right? You have to get a certain level of consistency before you do anything, before you actually run your code, run your tests, experiment, see what it does, check some feature that you've fleshed out and other features that are missing. You can't do any of that stuff. The world must be consistent before you move forward. Right? This is a huge problem. And there's generally brittleness in language design, evolving type systems. If you try to make a major addition to a type system for a language, you will find that is a difficult task. I can tell you personally. I'm not like Lyndon Johnson. I won't show you my wounds or anything, but it is a very, very difficult thing to evolve a type system for a language. If you do some decoupling, that gets easier. There's a long history to this, and I can't possibly go through it all. There's only one that we'll dwell on, of course, which is the one that I did. And Lars and I did, and others at the project that Strong Talk effort that eventually morphed into Hotspot in parts and so forth. So the idea there, because everybody has their own idea of what optional typing. There's all these things had in common is that they wanted the dynamic language flexibility, but they wanted some of the benefits of types, and there's different ways of skinning that cat. So the way I define optional typing is that syntactically optional. Everybody agrees about that, right? They don't want to type a lot. That's much less important, but that is part of it. The important thing is it doesn't affect the runtime semantics, which is far more subtle. The temptation, once you have a type system, to have it meddle with your execution is, for many people, overwhelming, right? Because knowledge is power, and power corrupts. And type systems give you knowledge, and the rest follows. Seriously, right, the typical situation in a mandatory type system is you've got this two-way dependency between the type checking mechanism and the execution mechanism. Right? Obviously, if you're going to type check your execution, there are probably people who don't even care if you execute anything as long as their type system is elegant and logical. But most of us actually think that there was a purpose beyond that. So clearly the type system in some sense is dependent on what kind of language you have and how you execute. The interesting thing is you almost always have a dependency the other way. Method type-based overloading, right? Which method gets executed depends what squiggles you put next to the variables in your type system. There are plenty of other examples, right? How you initialize, what values used to default initialize something might depend on what type was written next to the variable, etc. So it's tempting. You can see why it's tempting. It makes for language design is very brittle. It's everything affects everything else. That's why it's hard. And it's nice to try and decouple things, right? If you limit the dependency, say lambda calculus, actually, the reduction rules of the lambda calculus are not dependent on whether it's typed lambda calculus or not, right? It can tell you that according to these type rules, this is invalid, but it doesn't change what the thing that executes. Now, Phil Wadler will tell you that there's a whole alternate basis to all this, and you can start from types, and it's all good, and Phil's a very clever guy. But as an engineering matter, do we want this? That's controversial. I don't want it. That's very clear. And what this does is you can now evolve your language. You can evolve your type system without breaking programs because your execution mechanism isn't going to change, right? Once you've done that decoupling. That's a nice thing. Of course, the other thing people talk about are syntactically optional. That's the obvious thing people see on the surface, the syntax, right? And in fact, I'd argue that type inference, which is what people scream for when they having types and keeping it optional, relates to type checking in the same way as type checking relates to execution. What do I mean by that? I mean that I can draw similar boxes, right? So again, you can have a system where type inference and type checking are married together and mutually dependent. Hindley-Milner being the classic example, right? A type system was very carefully designed such that inference is possible for it. It makes certain compromises that presumably the people who designed it didn't care about or may not even have noticed, right? Like polymorphic recursion. Is that important? Sort of object-oriented programming, the style I do, it's very important. And, then you can publish papers about how to fix that. But there is a mutual dependency. Now, let's say you sever that dependency and say, my type system was designed with the assumption that I'll decorate everything, however tedious that might be. And then I will, as a separate matter, choose to see what I can infer. Since now my inference, for example, doesn't have to be sound. It can be heuristic. I can look at the variable names and look for hints. And well, I might infer something completely broken, but the world will no longer come to an end as a result of that. It can be a tool in my IDE. Please infer types for this thing. Stick them in. Then the type checker, which is a completely separate process, can look at this. So the idea here is in terms of language design, to try and not give in to the temptation to leverage all the knowledge you have everywhere, but to try and decouple things so that you might be able to evolve them separately, and you might have other options that you didn't have. So this is my opportunity to give you this spiel, which has been around for a long time, and this is kind of the slogan, don't get boxed in, right? There's a space of programs for which you could infer the types and check the types and whatever, and you can write many interesting programs in that little red box. I call it the penalty box. And then there's, then you can be taken out of solitary confinement, but you're still imprisoned where you can type check, but you haven't limited yourself by an inference algorithm. And then there's the yellow sunlit spaces of free execution with no types, right? Free love and all that. So don't get boxed in. That's kind of, we're really, the spirit of this is we don't want to limit programmers. Right? We don't believe that they have to be tied up in knots. We want to give them freedom in terms of their workflow, in terms of what programs they write, etc. On the other hand, there are advantages to types. Don't tell anyone, but there are actually real advantages to types. And I've listed them in an order that maybe not everyone agrees with, right? The great advantage of types is documentation. And mandatory types give, sound mandatory types give you machine checkable documentation, and that is really nice. Types help you think about your problem. They organize your universe. That's very important. Types find errors early. That is one of the most overrated memes in computer science. Right? It's useful, but depending on the ecosystem, depending on your tooling, it matters a great deal. If the cost of a mistake is disastrous, right? If it's then it makes sense to check as much earlier. If the cost of a mistake is not very critical, there's a trade-off, which is why you see things like, if you had to go to the computer center with your pile of cards and wait 3 days until, someone told you what was wrong, then maybe you couldn't type check them anyway because the type checker you'd have to wait 3 days for the data center's type checker to get you. But the cost is high and you evolve these systems. If you're at Xerox PARC and you have this thing that interactively does everything instantly and so forth, there was less need for that. I think that the coevolution of the tooling and the languages affects what you think of these type systems. And people have a very religious perspective on this, driven by their individual experience, which is why it's really good for people to play with different systems and the right ones, right? Because if you play with a bad system that you take as an exemplar of an idea, then it's even worse. So in other words, go play with Smalltalk or something before you say you have to have types. So this is a summary of the optional types idea. And we should probably show you how this actually works. At this point, now this will do. Right, so we had this completely dynamically typed program. But we could say something like this. And we could say something like this. What did I type here? And we could start. So now we have some types. And when we run this, it runs, but we have this little, hopefully this is visible up there. Yeah, we have this little lemon-colored thing. So points aren't assignable to numbers because, in fact, the scale method doesn't, give me a number. I was sort of confused. It gives me a point that's been scaled, right? So I do get a warning, but the thing still ran. It still printed this, right? The program is actually correct. It was a dynamically typed program. It's still correct. And, whatever squiggles you choose to point, do not make it incorrect. They are there to help you. You are not there to help it. That's the fundamental thing. That, there's no reason that just because this thing is in some temporary inconsistent state, you can't run the experiment and see what does work and what doesn't work, right? And this is core to the whole philosophy of Dart in a lot of other places. There's things that we're still changing in that light. So, for example, if you call a static method that isn't there, it's very obvious. It seems to be a compile time error, and we scream at you. We actually are going to loosen that up. We can give you a warning like this, and you can still run, because maybe you're not actually executing that call. Maybe it's just part of your code, and you haven't gotten to it yet, and maybe you want to run a different experiment. It's okay. You will know at development time, at the exact same time as you always know in a traditional language, there's a problem. But we're not there to slap you around, right? We are not there to force you to solve all those problems at once before you can do anything further, right? So they're warnings as opposed to errors. That's kind of the key thing. And of course, we have this thing in some inconsistent state. Now, if we allow this to go forward, we had better make sure that the types don't change the execution semantics, because otherwise, the mental hospitals will overflow with programmers who go nuts as every typo you make here will really mess up, the actual behavior of your program. So if you're doing a system like this, it is very important that you keep the execution semantics independent of these annotations. Right? Now we can keep going, and we can correct this, and we can put in, whatever this is. We can make these be points, right? And this is a point. And now it's starting to look like a Java program, right? And someone raised this point, I think, yesterday. Is it real, this process of moving from type to untyped? I think it's individual development style, but it certainly can be done. And you can present programs. And if you present it this way, the visceral response you get from different audiences is very different, right? The JavaScripters actually start to kind of worry, because there are a lot of people out there who don't actually want types. There are millions probably of people now programming with JavaScript who do not understand JavaScript's model at all. They just copy and paste, and they just want to get some stupid web page up, right? They don't know what a type is. They do not wish to know what a type is. We want to kind of keep this, while we want to guide them toward correctness, we do not want to force them into it, and we have to keep this low-key. So this is kind of the spirit of the thing. We're zoomed in, right? What next? Now we're going to go through this exercise again. So, review. Got that? Yeah. Okay. And so far so good. So what's actually new about this? What I've shown you, essentially nothing, right? Lars and I had this running in 1995 or so. I had it running in 93, really. So this is a screenshot of the Strongtalk system, and it shows you a hash method that is maltyped. So, the expression that's problematic is between these little red glyphs, and then in the bottom it would tell you that the type of the returned expression is integer, but that's not compatible with the declared return type. There is no declared return type. It says hash. It's the hash method. By default, and that's in Smalltalk, if you don't have a return, it returns the receiver, this or self, as it is in Smalltalk. Therefore, the type system, if you don't declare, says you return the self type. Right, if you don't declare anything. Well, this method is hash, it's an object, and the self type is not integer. But what it's returning is identity hash, which is typed as an integer. Obviously, there's an inconsistency. Equally obviously, if this actually was a problem for the thing to execute, this would all crumble into a rubble of bits, because this is a live system. This browser, the type checker, all this stuff, the entire system is written in itself, and if hash doesn't work, you're dead. And yet hash continues to work. So this is essentially the same kind of thing, except that it was a little less in your face, right? It was an explicit option to whether you wanted to type check or not. In Dart, we've sort of mandated that there is the optional type checking in development should be there. So that's not new. But what is new is that really, this mechanism should not be thought of as a type system at all, for different reasons. I haven't gone into the soundness, unsoundness thing. We don't want to be here all day. But it isn't a type system. This is what I said when I joined the Dart project, and they showed me this, and I had that same reaction because I still have never fully recovered from my PhD studies. And this isn't a type system. You shouldn't call it a type system. And once the froth kind of was wiped off my mouth and so forth, I was assimilated, and I now understand. The point is, really, it's a type assertion mechanism that is using these annotations, and you can leverage that in kind of interesting ways. So if we go back to our friendly Dart program, no, not this one, this one. So let's, I'm not sure what Pointy will do, but hang on. We're going to say check mode. Let's see what happens. Maybe this is Pointy may be undefined types we're very liberal at, but let's make it wrong just to be really sure. Yeah, right. So the stuff in red. Red is always very readable on slides, so I'm sure you can make it out. Yep, it's clear as mud. But what it says here is failed type check, and this is a dynamic check. Right? When you turn on that little button that says check mode, all these type annotations are treated as assertions and dynamically checked. Of course, this isn't sound. It might be another path. Blah 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 blah. I know all that stuff. It is immensely useful as a practical matter to be able to interpret all the places where you either assign a variable, pass a parameter, or return a value. Everywhere a value is being passed in some direction as something that we dynamically check. And this is, again, a development time tool. Why isn't it always on? A, because sometimes, it just may be the wrong thing, and you actually you're still doing something that we don't understand. But B, because, it's a little costly. And right now it's very costly. It'll probably get much better. It is on the list to optimize. But it'll still be significant cost. And, things like factors of 2 or whatever, there are a lot of people who are fussy about that. So it isn't on by default. There's production mode where the types do nothing, right? They do not affect your runtime semantics. But in development mode, you can choose to actually have them do this. It's essentially a debugging tool. It turns on, this mode also turns on all your explicit assertions, right? Which is a thing you're used to turning on and off between production and so forth. So, again. Right. So this is actually this slide shows you the definition of what it means, but essentially I've explained that. So checked mode. So this is something we didn't have in the past, and this is something that's new about Dart, and it's very useful as a practical matter. And Dart is nothing if not immensely practical and pragmatic. So it isn't a type system. It certainly isn't a type system in the very traditional sense, but it is a very useful tool, which some type systems are, and many type systems are less so. And really the idea is that this is just one tool in the programmer's arsenal, and it should never get in their way. It should always serve them. I said I wouldn't say anything about the soundness, but of course you are free, and there are a number of academics who are looking at this, right? You could interpret our annotations strictly and have a tool that went and complained, right? And in fact, there are people, we have with our flags in the current implementation that say, stop if there are type errors. If I had my way, the spec would say that you were forbidden from doing that. But there are people who like to be bullied, right? There are this masochistic school. They've programmed in Java too long, and, they can't be saved. But they want, you're getting the message anyway, right? But they want to be tied. Otherwise they might feel tempted, right? They, just don't let me execute it. I get the tremors. So you have that option, right? Because we're pragmatic. Not someone in the Dart project is pragmatic, not me. So you can interpret these things. Then you'd have invariant generics presumably, and there are people who argued that's good enough. I never argued that, but You might be able to add things. Eventually we might have some mechanism for, I'd like to have a mechanism so you could do pluggable types. I mean, it really is nice to have a sound system for some purposes. We do not preclude that precisely because we don't have a privileged system that influences the execution semantics. So now we have, what do we have? A few more minutes. I'll try to show you something interesting. Mirrors. So the idea of mirrors, Martin talked about that in his talk. So mirrors have reached Scala. That's really cool, amazing stuff, and I'm sure you all agree. I've been after him to do that for, since before Scala was named Scala. And of course, when he did it very, very thoroughly, far beyond what I expected. But the idea of mirrors goes back to Dave Unger's and Randy Smith's work on self back in, 25 years ago or so. And it involves basically having a separate object that reflects other objects, and we'll kind of touch a bit about what that means. It got used in Strongtalk. It's used in the Java world, not in Java Core Reflection, but it's used in JDI with the Java debugging interface. It was used in a system that Alan did way back. What is it called? Firewall? Yeah, right. So Alan did this for Smalltalk as well. He didn't call them mirrors, but he basically, same problem, same kind of flavor of solution. And in Java, it was done for debugging because there wasn't. They sort of found that Java reflection wouldn't cut it for the reasons that I'll explain in a moment. I've done it in Newspeak, and now we're doing this for Dart. And yeah, the Newspeak mirrors are kind of probably the closest thing to the Dart mirrors, but Dart has its own twists. So just to recap what mirrors are, classical reflection in the OO style, going back again to Smalltalk. Every object has some method that'll get you its class. And the class is considered the reflective, the gateway to reflection. You can get the methods, the fields, whatever. It varies with the language. Mirrors change that. Mirrors say there's a separate object that reflects other objects. The object itself does not carry the seeds of its own reflection, as it were. And that has certain advantages. If you don't have a mirror in a traditional system, it's reflective. You can always reflect on everything, and there's no real way to shut it off. Java struggles to just start looking up the stack and who's calling and the wonders of the Java security model, and if you like that sort of thing, more power to you. But mirrors give you a clean solution for that. They give you clean solutions for deployment if you don't want to have reflection because it's a small device or, the download to the web page is too big in our instance. Well, if there are no mirrors used, you know that you aren't using reflection. You can get rid of all that information. There are problems with distribution. If you have a remote process and you want to debug it through mirrors, well, now you have a proxy to objects on the other side, and you ask the proxy what its class is, and it tells you it's a proxy, and that's very helpful if you want to display the class of the actual object you're looking at. So there's a problem there that, again, you can have a distributed implementation of mirrors that gets around that. Security, obviously, you can, if you don't trust the code to reflect, you can not give them mirrors or give them limited mirrors and so forth. So mirrors have many nice properties, which is why they're getting more popular for reflection. You can read about it. I had a blog post probably a year ago somewhere. Alan's had blog posts about doing this in JavaScript, though unless you shut down all the rest, you sort of don't really have all the advantages, right? To really leverage this, you need to have a system where the only reflection mechanism is mirrors. There's a paper that Dave Unger and I wrote way back, which is kind of a standard reference for this. There's a video of a talk somewhere on the web that you can look over, which I gave, and so forth. So there's plenty of information if you have insomnia. Now, Dart's mirrors will show you a brief example, and it'll highlight some of the issues we're grappling with right now, because they're not there yet. We're supposed to produce them. So the idea is Dart has these things called isolates, these actor-ish things, and you should be able to reflect from one. One isolate should be able to reflect on another. Thank you. So that unfortunately means that the API isn't always synchronous, which is a bit of a pain, as Matt's explained, and we'll show that. And so generally the goal of the design is to minimize the asynchrony as much as possible, and it's still evolving. So here's just a quick sample of introspection. There's an intent to have mirror builders that let you change code on the fly and whatever in certain circumstances, right? There's a tension between that and the various web things and optimization, etc. But at least for development, all the good stuff will be there. But introspection is what I'll show you right now. So we're going to assume we got an object mirror from somewhere. And yeah, this code has types. I often write types in my code, even if they're wrong, because yeah, the main value is documentation. And so once we have an object mirror, if we had a synchronous API, which is sort of modeled after the Newspeak API, right? We could ask the mirror for its class. The mirror will get you its class. A regular object won't get you its class. You cannot get the class of a regular object in Dart at all. There's nothing that will give you that answer, at least for now. And if it does, it'll give you something that will be very limited in its utility. You'll get a class mirror back. Not a class mirror, an object that's reflecting it, right? And then you can go on in this thing, and we're going to try and print out the names and values of the fields of this object. So there's a for loop, and we get the fields out of the class mirror. The fields, what comes back to you is actually a map of names to variable mirrors. And right now, mirror maps are not collections in Dart. I'm not sure if that will change. That's up to Josh, but they're not. So I get the keys, which will give me a list of strings, right? Here. It's useful to have. This stuff eventually should work for real, right? But since the mirror API isn't real yet, otherwise I could demo this in this Eclipse thing, which will actually do the code completion and stuff when you have types. But essentially at this point, we got this map of strings to variable mirrors. We get the keys, which will give me a list of strings, which are the names of the fields. And then I'm going to call a map function on that, take a name, and produce a pair. Basically, this is a literal list. And you can see that the first element is going to be the name, and the other thing is going to be an invocation on the object mirror that's going to get me the value back from that field. So I ask the object mirror to invoke the thing named f, which is the name. There are no positional arguments, so there's an empty literal list there with square brackets. There's an empty literal map for all the named arguments, because Dart also supports name arguments. We're not going to get into those details, but that just explains how the call works. And then we print this stuff. Unfortunately, as it looks like now, we may not be able to give you that because of the asynchrony issue. So the way it seems to look at the moment, all the red stuff is the beauty of asynchrony. And so when you ask the object mirror for its class, you get a future for a class mirror, right? We heard all about futures yesterday. And that future, whatever the call was, it's called in .NET continue with or something, right? So that's called then. It's a little different. You give it a closure. The closure expects the result, the resolved future, the value should be passed to that closure. And so we're going to get a class mirror in, and then we're going to ask it to do this stuff. And eventually we're going to have a problem here again, because the object mirror, when we invoke stuff, is actually going to give us a future as well, because we're invoking on a potentially remote object. And so we're really going to get a future on that result. And that's okay. We're basically going to ask that future again. The future is the second element of this list. So it's P1, because we start indexing with 0, like so many programmers like. And then we pass it a closure. They'll take that value, and then it'll be ready to print along with the name, which was the first element of that list. So, it was prettier before. We might be able to cut back on some of this pain. Like, it may make sense, for example, to say if you're getting an object from which is probably remote, suck in the class at that time so that we don't have to go through an extra cycle. Because maybe not, but there's a good chance you'll want the class at that point. So we may be making these compromises as to how much data to suck in at one point to minimize the number of ping pongs that you have to do. So we're experimenting with that stuff, and then it might look like this. And then, well, this is actually almost reasonable, right? And once you do introspection on the class, you notice we did not have to actually do futures to get at the fields of the class, because the assumption there is definitely if you're getting the class, we're going to suck in enough information so you won't have to ask what the names of all the fields is by going back to the remote thing and so forth. So we try to minimize that. Now, of course, it might be nicer if we had something like await. In fact, we're thinking about something like await. It's even more complicated than .NET because we have to compile this to JavaScript, and we, it's under consideration, but it'll probably be a while before any sugar like that happens for asynchrony. We're also looking at other options, promise pipelining. No decisions have been made, right? We're a technology preview. We're nowhere near, telling you to go and bet your life on this stuff. It has changed. We will break you right and left. But this is kind of the flavor of the stuff that we're going to do. We support things like no such method, which is the equivalent of does not understand. So you don't need a type provider in order to look at something on the web and produce a class. You can do it all dynamically the way, say, Ruby or Python would do it. That sort of thing. But you will need the right mirrors, right? Because the mirrors do control what power you have and therefore give us security and all kinds of nice features. So this is just a flavor of where we're going. There's some other twist to this business, right? So the web has this beautiful idea called minification, where they, since there's no binary, they sort of mangle your code. Well, there's obfuscation where they mangle it, and there's minification where they kind of twist it, right? The problem is with reflection, if things get thrown out by the minifier, well, you're not going to be able to reflect on them, right? So there's several options you can take there. You say, well, if you're using mirrors, well, we won't minify at all. That may be a bit extreme. Otherwise, you need a mechanism to selectively say, well, even though the code is not using this stuff and the minifier might think that it can be thrown away, don't throw it away, because I know I will eventually reflect on it. And you could do that in the context of a deployment tool or something else. We haven't figured out exactly how we'll do it, but we will have a solution for that. And so, it's more likely that we'll do that one. So that's another one of the peculiar twists that are different in Dart. So I'm out of time. Just been able to give you a bit of a flavor of what we're doing with Dart. New programming language. You should be able to deploy it to any modern web browser. What's the value of modern? Probably IE 9 and above, Firefox 9, Chrome, any version. You'll be able to do that by simply compiling to JavaScript. People ask about, like, will you put it in Chrome, the Dart VM directly? It's a thought. There's no decision made about that. But you can certainly, the idea is you'd use the Dart VM on the server side. And, if you did put the VM in a browser, you'd get better performance. I haven't talked about snapshotting. There's solutions to high performance startup, various cool things that we can do. Eventually, the world might get there, but that's not happening just right now. Again, the goal is to make it so that you never have to write a native app, right? Basically, we want to get eventually to the point where web apps are everything. It's just the easiest and best way to do things. As I said, it's a technology preview. It's all open source under BSD. There's a place called dartlang.org where you can download everything. There's forums, blah, 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 all the usual good stuff. Community, liberté, fraternité, égalité, communité. All that good stuff. So that's kind of the fast tour of things that I'm interested in Dart. There's lots more. There are people doing all kinds of other stuff, and thank you for suffering through it.
I think there might be time for a question or two.
Hi. I was wondering if you're also planning to include the proxy API and the intercession API.
So I'm not sure. Well, I don't know what APIs. Every known feature, every known API has been proposed. I'm not sure what right. So you have this actor mechanism, right? So in fact, you can talk through the actors to remote things. So I'm not quite sure. Now there are limitations on the actors. You send messages that include values or arrays or lists of values. Structures made out of values and so forth recursively. If you need to send objects, you need to serialize. So you can imagine putting fancier mechanisms on that. In fact, there was a proxy API, wasn't there? I don't know what became of it, where it is. Don't know the answer to that, basically. But dartlang.org, there's a forum, ask. We're pretty good at answering stuff.
So as a programmer, I really like that because all I hear is it's much easier to write programs. Great. Why didn't I come up with this idea? And then I'm switching to the user mode, and I'm thinking, all I'm hearing is it's much easier to write buggy programs.
Okay, so you have a bias, which many people suffer from, and it's probably not possible for me to cure you, but I'll try, right? So, one of our great advantages is what we're competing against, right? So it is not easier to write buggy programs. Well, regardless of what you believe about types, the alternative is one of the finest mechanisms for writing buggy programs that I know of, okay? Now, beyond that, you're alluding that presumably, I'm reading in and tell me if I'm reading wrongly, but presumably you're saying, oh, I can write things and the types are inconsistent and whatever, right? And that's a bad thing. Well, actually, this is a point of disagreement, right? Based on people's experience or whatever, the correlation between correctness and type checking is, again, one of those things that is, that people will get up on a barricade, but there is not a shred of scientific evidence. And depending on your experience, right, I don't believe in it. Right? I've written Smalltalk programs for years. It doesn't matter. That's not what the types are for. They're there for documentation, to help the tools, so I can get code completion, productivity. They can help with refactoring, even if they're not sound. Refactoring was invented in Smalltalk without any types. Eclipse refactoring is not sound anyway. But so there are lots of advantages to types. But as I said, when I made the list, error detection is very down on the list, and we can have a religious war about that. But that is not the problem. And if you really believe that, write the whole, put types everywhere. Write yourself. Someone will come up with a tool that will interpret them soundly, so you'll be really in a straitjacket, and you can do that, right? We're not precluding that, but it doesn't really. I don't accept the assumption of the question, right? It doesn't affect how buggy your programs are as long as your tooling is good.
So I see there are many more questions. Why don't we do so that Luke can start setting up and we can take questions while he's setting up? And there's one right here.
So there are two issues you brought up in the beginning of the talk. So writing large programs and making them performant. So I wanted to ask you where things stand on both of these fronts at the moment, and sort of where things are going.
Okay, making things. You'll remind me what.
So
the first
modularity and writing large programs, big programs, and
so there is
performance.
a mechanism for modularity that is very conventional, and so I've done a lot of work on modularity, and obviously you can think of more powerful mechanisms than what we're doing, but we are again not trying to deliver too many shocks to the system. So there is a library mechanism with imports. Which, there's a privacy mechanism that allows you to declare things private to the library. It's library-based. It's not object-based. It's not class-based. It's per library. That's your unit of privacy. That relies on naming, right? We basically take what is often a convention and we enforce it. So if you start your name with an underscore, it's private to the library. And, there are pros and cons to that. The pros are that, you can see instantly if something's private. It's context-free. The downsides are more complicated, but maybe obvious to lots of people here. Then, as far as performance, so the Dart to JS comes pretty close to the native JavaScript, I think, at this point. The VM is actually, at this point, slower, but the VM is probably faster than V8 was when it came out in beta. So we're in a respectable form, and give it, some time. Obviously, there's been several years of work on V8, by some of the same people. So they kind of know what they're doing. The expectation is that we will be significantly faster than V8 in the foreseeable future on the VM side. So I guess that as much as I can answer, right here.
So you talked about programming on the web, and so Dart answers some of those questions, but the other part is like interacting with the DOM. And I don't know, can you say anything about this? This seems to be like the other half of programming on the web.
Yes, I can say something about this. Would you like me to? So sure, there is some controversy actually, or between different people, both in the Dart team and not so much in the Dart team, but say in Google and various places. On the one hand, many people are are habituated to using these standard, quote, mechanisms of the web, the DOM, whatever. If you write one of these things, I find it unspeakable, frankly, but we are providing DOM wrappers where there's a DOM library, there's a wrapper library called HTML, which kind of makes it a little prettier, and maybe we'll settle on on the nicer one and whatever. In my view, no one should ever see that stuff, right, except the plumbers. And so there should be a nice UI framework. There are some UI code. The Swarm application I showed you has libraries for UI with touch, whatever, but they're incomplete. They're exactly what was needed to do that demo in some sense. So there's a lot of things that are missing. I expect them to come along both from us and from third parties. And my view is that programs should not be talking to the DOM directly, but that's a controversial statement.
All right, thanks.